All right. Hi, everybody. Let's see if I'm live. Looks good. Am I live? Yes. Think so. Yes. All right. People are coming in. Hello. Hello. All right. I'm back. I'm back after yesterday's problems. Yes. Hi. Rupesh. Oh. Good, good. I'm good. I'm good. Yesterday, I'm also back on YouTube. I'm back. Hey. Hi, Alex. Christian. Hey. Yeah, yesterday I actually got on YouTube a community guideline strike because I was streaming a commentary on that video from Cold Fusion. And I was like, oh, what's that now? And it was actually my first one. So then I cut the stream early and then I appealed the strike. And this morning I woke up and everything was like they said, okay, we checked it and it's okay. We reverted it and you're fine again. And it's even the video on YouTube is back online. So Nolan, hey, hello, Ignesh, hi. Yeah, I want to use this today. I have one thing. I have a case study that I want to show you about building a data lake using AWS well architected. That's from Bayer, the pharma and so on company. And I actually found this. It's not going to be a video. It's just a presentation, and I want to go through this with you. And also answer any questions you have. I did an Instagram live this morning, so if you want to check that out as well, you can find me Learn Data Engineering on Instagram. It's my face in the thing, so check that out. I'm also collecting questions there almost every day, so if you have questions, you can also go there. So yeah. Again, today's topic, data lakes, and any question you have. So let me know in the comment, in the chat, of what you have regarding data engineering, regarding how to get into it, and so on and so on. We can already jump into the Bayer thing, and then I'm going to, in parallel, answer your questions that you have. Okay. So, as I said up here, the idea, let me bring this up. So the idea here with this centralize and standardize data from Carbon Program using AWS to help Brazilian farmers adopt climate smart agriculture practices. So it's an agriculture use case. You can also read about this here. Search for this in Google search. And after our stream, I'm going to put this also in the chat here, in the description of the video. Now let me make it so that maybe you can see it without me in it, because I haven't actually brought up the green screen today. Oh, it's too small, so like this. Okay. So how this works, the idea of this is, can I remove the console here? No. So what they have is in the center here, we have our AWS cloud right here, this. And the interesting part is also on the left here, they have the data sources. So they have partner sources and they have partner APIs. And this is usually how you get data in. So where the data lies and how to get the data in. And this is pretty standard. You have CSV files. They drop it into SharePoints, and you have APIs that they are going to query. And let me quickly check. Yeah. And so then in the middle, they basically built their data lake. And what they did here is they have here load external data Lambda functions. And this is how they actually load the data into this whole thing, right? They schedule the Lambda function here, scheduled events. That's most likely something like EventBridge or something, where they go in and they get the data, and they trigger the Lambda functions to get the data, right? So this arrow that we see here, this should be different. This should actually point in this direction here, right? Because it's going to look outside and going to basically pull the data in, not getting the data pushed. And from there, they are putting it into S3 buckets. And they have, sometimes when we speak of data warehouses, we speak of bronze, silver, and gold tables, right? And this, you could say this is like the origin. They mark this origin bucket. Then they have the bronze bucket, which is raw data, and the silver bucket, which is prepared data, so cleaned data. And then most likely what they do here in Redshift, in the data warehouse, that's your gold layer, right? So I think that is pretty neatly done with buckets, where the data goes and where the data is categorized into the different grades. Let's say grades. Are you familiar with this topic? Let me know in the chat if you're familiar with the topic of these. How can I remove this here? But yeah, so that you have your data here. Basically, this below here, that's the data layer. We could also mark this here. This here is our data layer, right? The blue one. And then we have the processing layer on top, where we have our data catalogs. This means they classify how the data looks in each of these, right? So this here, raw and prepared. So this all will show the actual structure of the files that are in this. And then on the top, they have glue, which actually then does the processing of this. Sanitization, masking, so masking data that shouldn't be visible, it should be private. They aggregate data, they prepare data. Sanitization, most likely they mean something like cleaning the data. And that's basically what they do here. So they send the data from this way on your screen, from left to right, and use glue to process the data, laying from the catalog, laying in the S3 buckets, right? So I think that's a pretty neat solution, what they do here. The problem is I can't really zoom this, because if I try to zoom this more, then the menu bar on top goes so big. Hey Andreas, long time since I have been here. Yeah, hey, hi. 2020 core, I remember. So you're still doing the data engineering architecture series? Yes, I'm starting this up again. Yeah, I'm good. I Can't complain. Can't complain. All good. I hope with you as well. What's the perfect architecture design for complete data lake and data warehouse using AWS? Yeah, I think that's already what we're looking here, right? You have the different stages, how the data is organized here in the buckets, and then basically what the processing does is the processing takes the data from here, takes it up, loads it in, and then stores it back down. And then the same thing again here, this way, and then stores it again in this, and uses the data catalogs to actually then clarify how is the structure. And from there it goes to Redshift. And then on the right you have your, so these are the gold tables. And then on the right you have your consumers, Bayer, Sensidia API platform, right? And it's also interesting how they run this. Pretty simple. They run an API gateway where you can make external calls too. In the background are Lambda functions, just like the Lambda function here, but not that it queries an API, but it's getting triggered by the API, and then it loads the data. So it basically goes the other way around here. The client makes a call. This triggers the Lambda function. The Lambda function then communicates with Redshift and loads the data into Redshift and delivers it to the client. And the authorization, that's done here with Cognito. So for the client. And this way you can your client has you can have different clients with different rights, because within your the right side here is basically the API gateway, the API handler, Lambda function, and Redshift. That's your client facing infrastructure, or where the data is. So you know who's coming in, you know you know how they can access the data. You can say, okay, this client is only allowed to see this data. This client is only allowed to see this data. If you have different partner sources, like let's say you have another partner here, P2, then you could say, okay, you load the data from this P2 partner, load it in, put it through the S3 buckets. It will come into the Redshift, and then in the Redshift you say, okay, only P2 clients can actually see the P2 data here, because here will be P1 and P2 data. They can see then only their data. And it's pretty simple. They don't, where the data is together, where you have basically the data from the left, from the individual partners, goes all into buckets, and this could be thrown into the same buckets. But because the customers don't have access to the raw buckets, to the origin, the raw, and the prepared bucket, they that doesn't matter. They only work with Redshift, and I think that's a really, really cool function. Now you could say, okay, let's make this even better. Let's add here API again. Right? You could add on the right API gateway, so that clients could actually send data over into the API and could more or less stream the data. Oh, I'm sorry, you don't see this. How can I make this? Oops. It doesn't let me. Let me try to. Can I get out of the way? I can't get out of the way. So basically, on the left here, I created APIs, and the client can actually then access the API. Let me try if I can make. Yeah, here. So you have then here, client can send data to your API that is within your data lake, and can send the data through. It's pretty neat. I really like this. And that's how you build it. Now the question is, yes, would you use Glue here and the Glue data catalog? You could. You could also build this in a way that you say, I'm changing this. I'm replacing Glue and the Glue data catalog with Databricks, for instance. Then what you would do is you would go in here. You would say, okay, let's delete this part here, and let's put here above. That's wrong. Let's put here Databricks. And then keep your buckets below. And you could even use Redshift, or you could also change out Redshift that this goes into Databricks, or you just use the processing from Databricks. It's like there are a lot of options that you could use, that you could do. Hey Santiago, hi. How can we connect Apache Spark with S3 buckets instead of using Glue? Yeah, that's what I meant. Like, yes, you could run here. Well, Glue, we can run Spark jobs within Glue, right? So that's the thing. You would not need to host a Spark instance here. You could just use Glue, or you could say, let's change this out as that and make this Databricks. Would also work. Pretty nice. I mean, what do you think? Let me know what you think. I know there's a bit of a delay, but does that make sense to you? I think that for me that makes a lot of sense. How they built this that API is on the right. It's very easy for clients to access the data. You have your Redshift, that is the central, let's say that is the central storage for the data that is then used by the clients. How expensive is Glue? That depends on your workloads, how expensive Glue is. Because Glue depends on how many instances you're running and what instance type, I think, when I remember correctly, you're running. So that's, if you process a lot of data, this can get expensive. Yeah, that's always the case. So, but how expensive? Basically, S3, the S3 buckets are going to be dead cheap. Redshift is not, depending on your workload from the clients, basically because they're querying data right this way. Depends on the workload from your clients how expensive Redshift is. API gateway and this is not going to be expensive. This most likely is also not going to be super expensive. The Lambda function that actually loads data from the clients here. So depends on how often you run this and how much data you process, but it's not. So in that, it's always the same thing. The processing is always the most expensive stuff here. Yeah, that's it. That's what I wanted to show you. How a data lake looks, how they built the data lake here. I really like this. I like the silver, gold, and origins raw, basically origins, bronze, silver, and gold table approach or bucket approach. And Glue as the central processing with data catalogs for each bucket. It's pretty nice. Something else. Let me while I wait for your questions. Let me plug my academy. If you want to learn data engineering, of course you can go to learndataengineering.com with my academy. Click on the academy, and this is basically what you need. If you here also for beginners and professionals, for data engineers, basically want to take the next step. People who start out or want to join data, become a data engineer or get into the data engineering field, or also for scientists. I have a lot of scientists in the field in the academy who want to actually get good because they need it. And here I have a long list of all available trainings that you can check out. It's over 40 hours with basically 4 modules. And this is how I train over 40 hours. Just like this, where I'm in the screen and I'm showing you around. We're doing source codes. We have individual help channels on Discord. If you have a question, you can always ask and get help from me. And also I'm doing their basically free mentoring through the Discord and every other week through office hours. So yeah, that's what I do. Any more questions? Was there something else? Any solution for gap years? I'm from non-IT field. I'm not sure what you mean with this, Sandeep. What do you think about ChatGPT? Well, we actually did a stream yesterday about ChatGPT. Check out my LinkedIn. There was a stream about ChatGPT, and we were looking at a video about ChatGPT. So that will be helpful, Nurlan. Iceberg similar to Data Lake. Oh man, I'm not super deep in the iceberg topic. There are other people better than me to talk about this. My glasses are always crooked. Is this better or this better? This better. All right. I see no more questions. Nobody gives a shit anymore. Yeah, if it's absolutely no problem. I showed you what I wanted to show you. I wanted to show up and say that I'm back on YouTube and not going anywhere. As I said, if you have questions about this, about data engineering, also let me bring this up here on my phone. Or can I bring up Instagram here now? No, I think you cannot look at our data engineering. No. Oh. That's the wrong channel. I can't find it. Yeah, you can find me on Instagram under Learn Data Engineering, and there I can help you. You can ask questions, and I can also give you answers there. So high level math you need. Listen, this is that's a funny thing, Christian. This morning I answered the same question on Instagram. This is not like data science where you need to be good at statistics or probability stuff and so on. Most math you need here is like the standard stuff you learn at school. Sometimes you need an average. Sometimes you need to uh, aggregate some values. Sometimes you need a min max, because most of the time what you're going to do is you're going to not analyze the data, but find out statistics about the data. One of the important things is that you understand, how do my pipelines behave right now? And that is something that you can very, very easily with very simple math do. So it's not a big deal. Absolutely not. Yeah. Difference between infrastructure engineering versus data engineering path. I think for me, these are very, very much, or these are very close together. The infrastructure engineering most likely is more about the architecture, is more about setting up the thing. So, whereas the data engineer is more concerned with the actual data, usually with using the tools and trying to get the data from the ingestion, just like we've seen with our data lake. On the right were the sources. Then let's get the data in, let's process the data, and then let's find a way how to make this accessible to the end user. And the end user could be someone like you and me, who wants to look at their purchases on the website, or a data analyst or a data scientist. So that's I think that's the difference. The data engineer is more concerned in the first place with the data and processing the data, and the infrastructure engineer is more geared towards setting up the infrastructure, running the infrastructure, and so on. My math is functional at best. Great here. Don't worry about the math. Master SQL, yeah, that's also something you should do. Yeah. Because without that, it's going to be terrible. Yeah. What's your opinion on Apache Beam? I haven't used Apache Beam. I know on GCP, Apache Beam is very, very strong. People use it a lot there. I have heard it's nice to work with because it's easy, and it's very generic how you can set up the processing and then execute the processing steps. But I'm not proficient with that. Haven't looked into it. Maybe I need to get better with it. Yeah. Otherwise, this morning I've been working on the new recruiting course, because I posted about this yesterday. I'm also going to make a video about this, a separate video. I posted yesterday about this, that I'm starting again a recruiting service for my students. So everybody who went through the academy or is a student, I'm going to try to find them a job. The problem is, of course, the other side, not the students, because I have a lot of students, over 1,000 students available that I can contact. The other side, the company side, is the problem. Finding a few good clients who actually are interested in hiring data engineers. And then the connection should be fairly simple, but the finding a client, that's difficult. That's difficult. But I need to set something up. It's not going to be expensive for companies. Not like that they have to pay tens of thousands of dollars in the beginning. So yeah, that's something I'm working on right now. And for that, I'm creating a course in the academy where people can actually go through, understand what is like, how can you what's a good CV, how can you create a good CV, how can you prepare for the job interview and for the stages, how to do salary, how to negotiate salary, how to analyze job descriptions, how to build a portfolio of projects, and so on. That's what I'm currently working on. Yeah. Okay. Then I wish you all have a nice Friday and a nice weekend. I'm going to try to relax a bit on the weekend and then be back on Monday, most likely with a new episode here. Yeah, I'm still terrible of telling you when I'm going to be live, but yeah, that's how I am. Okay, so have a good one, everybody. We see each other next week. I hope this was fun for you. I'm going to most likely create a separate video out of this with this snippet of the data lake. Yeah. Awesome future of Databricks and Airflow. What after the cloud? I'm not going to answer that right now, Vivek. So, yep. Santiago, everybody, thanks. Have a good one.